Welcome to week 3 of virtual learning. This week we have 2 lessons that we're going to go through. The first will be probability of simple events, which is lesson 10.6. The second will be on the differences between theoretical probability and experimental probability. For each lesson, you'll have a worksheet to complete. They should be relatively quick. They shouldn't take a long amount of time to complete. But this week we do have 2 separate worksheets to complete with practice on each of these lessons. Remember, pause the video at any time if you want to do some practice on your own, or you want to try some of the problems on your own, or you just want to go back and watch some parts of the video again. So let's first start by talking about simple probability and some key vocabulary related to it. So a simple event is one outcome or a collection of outcomes or results. Some examples include choosing a Scrabble tile, selecting a card from a deck of cards, rolling a die. Those are examples of simple events. And we'll be doing some examples of finding the probability of simple events. For example, what's the probability of rolling a 6 on a standard 6-sided die? What's the probability of choosing a red marble from a jar of colored marbles? That kind of thing. So probability is something you've seen before, and I found from experience that students have a tendency to do pretty well with probability. So this is something that may come pretty easy to you. So the probability is the chances of an event happening. Now the format might be a little new for you. You're going to see something that looks a lot like this, a P, and then some sort of event in parentheses. What this means is the probability of that event occurring. So you might see P and then in parentheses 5 or P and then in parentheses 6. It means what's the probability of rolling a 5? What's the probability of rolling a 6? The numerator will be the number of favorable outcomes, and the denominator is always going to be your total number of outcomes, the total number of things that could occur. And you've seen that before. We'll typically write probability as fractions in simplest form. We will probably also write a lot of them as percentages as well, just to get some practice with that. So we'll talk about how to do that. Pay attention, because that's where a lot of Math 7 students a couple of weeks ago had some issues with their assignment. The probability is always going to fall somewhere between 0 and 1 on this scale here. The closer the probability is to 1, the more likely it is to happen. In fact, if it has a probability of 1 or 100%, it means it's definitely going to happen. For example, right now as I'm recording this video, the probability of it raining is 100%, meaning it's definitely going to happen, and it is happening right now. And then the closer the probability is to 0, the less likely that event is to happen. So it means it could be impossible. In fact, if it has a probability of 0, it means it's not possible. And we'll have an example of working with that in our guided notes here today. So let's do some simple probability examples. So a bag contains 5 red marbles, 5 blue marbles, 6 green marbles, 8 purple marbles, and 1 white marble. One is selected at random, meaning without any sort of preference. Find the probability of each outcome. Express each probability as a fraction and as a percent. We'll talk about how to do that. The first thing you want to do is count up how many total marbles there are, and you want to make sure you do that correct or all of the parts are going to be incorrect. So take a moment, count up how many marbles there are. All right, hopefully you determined that there are 25 marbles. So number 1, when it says find the probability of white, it means what's the probability we select a white marble? Well, there is 1 white marble out of the 25 total, and that is 4%. And you might wonder, how did you get 4%? There's 2 ways. Do 1 divided by 25 in your calculator. That will get you 0.04, which is 4%. Remember, we moved the decimal point to the right 2 places. The other option is rewrite it with the denominator of 100. So 1 over 25 multiplied top and bottom by 4 gets you 4 out of 100, which is 4%. Number 2, probability of red means the probability of selecting a red marble. Well, there are 5 out of 25. Don't forget to reduce that. If you can plug it into your calculator, great. I know some of you don't have calculators at home. So just divide both 5 and 25 by 5 to get 1/5, which is 20%. If you don't have a calculator at home, again, you should still try to reduce it. It's something you've been doing since elementary school. So please, most of the fractions are pretty easy, so you should be able to reduce them. And I know, you've got calculators on your cell phone, you've got calculators on the computer, do the best that you can with that. I want to see an attempt to reduce the fractions. Number 3, probability of selecting a green marble. Well, there are 6 green marbles out of 25. 6 divided by 25 is 0.24, which is 24%. Now, I know I'm going to slide this up and we're not going to be able to see the directions, but hopefully you have them in front of you to look at as well. So number 4, probability of selecting a purple marble. Well, there are 8 purple marbles out of 25. 8 divided by 25 is 0.32, which is 32%. Now, number 5, what's the probability of selecting a marble that's not red? We'll count up all the other colors, the blue, the green, the purple, and the white. And we will get 5 plus 6 plus 8 plus 1, which is 20 marbles out of 25. Reduce that to 4/5, which is 80%. Now, if you do the probability of red, that is 5 out of 25, which is 20%. And so for it not being red, not surprisingly, is 80%. They should total 100. Number 6, the probability of selecting a marble that is not green. We'll add up the colors that are not green. So that includes red, blue, purple, and white to get 19. 19 out of 25, take 19 divided by 25 to get 76%, or 0.76. Now, pay attention to 7 and 8, because again, Math 7 struggled a bit with this. Number 7, it says, what's the probability of selecting green or purple? That doesn't mean that you just choose one of them. It means that what's the probability that when I select a marble that it's either green or purple? Now you can find the probabilities of each separately, but you need to add them together. So what I did was I did it all together. There are, whoa, sorry about that. There are 6 green. There are 8 purple, which totals to 14 marbles. So that will be 14 25ths, which is 56%. Again, you could do 6 25ths plus 8 25ths. Either way, it's going to get you 14 25ths total. Now, green, purple, or white. So we need to add in that one white marble to get 15 out of 25. That reduces to 3/5, which is 60%. Again, as a reminder, you can do 3 divided by 5, gets you 0.6. That is equivalent to 60%. Number 9, this is an interesting question. We want to give an example of an impossible event. Well, it's something that's not possible to occur. So I gave an example here based on the directions. You may have something different. But for example, the probability of selecting a brown marble. There are no brown marbles in this jar, so this is an impossible event. All right, let's move on to our next problem. Number 10, a bowl contains green, red, and purple grapes. A grape is selected at random. If the probability of selecting a red is 1/2 and the probability of selecting a green is 1/5, find the probability of selecting a purple grape. Well, in this problem, let's add the 1/2 and the 1/5 to figure out the total probability of selecting red or green, which will be 7/10. So if all we have left in this bowl is purple grapes, let's do 1 or 100% and subtract off the 7/10, which is 3/10. And again, if you have a calculator, that makes things a little easier, but you should have 3/10 left over. So this is the solution. Let me go ahead and circle it here. You have a 30% or a 3/10 chance of selecting a purple grape. All right, number 11. This is a good problem for us. Nice multiple choice question. A bowl contains 12 green apples, 8 red apples, and 10 yellow apples. Bobby randomly selects an apple from the bowl. Which of the following statements is true? So for this problem, I think it benefits us to go through each choice and think about if it's correct. Letter A. He is equally likely to select a green apple as a yellow apple. Well, we have 12 green apples and 10 yellow apples, so it's actually more likely to select the green apple than the yellow apple. So we can eliminate choice A. B. He is less likely to select a green apple than a yellow apple. Well, we just said it's actually more likely since there's more green apples. Eliminate that. C. He is more likely to select a red apple than a yellow apple. Well, we have 8 red, 10 yellow, It's actually less likely. Does that mean it's actually going to happen? No, but it is still less likely. So we're assuming D is correct. Let's read through it. He is more likely to select a yellow apple than a red apple. Well, there are 10 yellow, 8 red. It is more likely. Does that mean that you would necessarily select a yellow apple more often? Not necessarily. And that's the difference between theoretical and experimental probability, which we'll talk about in the next video. But choice D is the correct solution. All right, number 12. A jar contains marbles as shown in the table below. 12. What is the probability that Brandon will select an orange marble or a green marble? Write your answer as a fraction in simplest form and as a percent. First of all, you want to calculate the total number of marbles that are in this jar. So add up 15, 13, 15, and 7. We should get a total of 50 marbles. So we count orange and green. We need to total these together, the 15 plus 7. Don't forget to add them together to get 22 out of 50. That will reduce to 11/25, which is 44%. Now, a couple of true-false questions. So number 13, true or false, Brandon is equally likely to select a red marble as he is to select a green marble. Well, for red, we have 15, and for green, we also have 15. This is true. Let me see if we can delete this. This is true because he has the same number of each color. Number 14, Brandon is less likely to select a blue marble as he is to select an orange marble. Well, this is false. We have more blue than we do orange, which means it's actually more likely for him to select a blue marble. Again, does this mean if we made, let's say, 10 selections, we would select more blue than orange? Not necessarily, because again, experimental probability may look a little different than theoretical probability. All right, number 15, moving right along through these. A cube is painted on one side. 3 sides are green, 2 sides are yellow, and 1 side is purple. What is the probability that when it is rolled, it will land yellow side up? Write your answer as a fraction in simplest form. Well, 2 of the sides are yellow. There are 6 total sides. 2 6 reduces to 1/3. If you want to write that as a percent, it'll be about 33.3 repeating percent. Will be exactly that. Number 16, and by the way, on your practice sheet, you have a problem just like 15 and just like 16. A teacher is distributing donuts to her 20 students. She has 8 glazed, 5 chocolate frosted, 6 vanilla frosted, and 1 cinnamon sugar donut. Lily does not like chocolate or vanilla frosted donuts. What is the probability that Lily will get a donut that she likes? Well, when we look at a problem like this, we can eliminate the choices that she does not like. So there's 20 total donuts, 20 students, 20 donuts, 8, 5, 6, and 1. We know that she does like glazed and cinnamon sugar. So we can eliminate, let's see if it'll let me cross this out. I know I had some issues with this before. Let's kind of cross out the 6 vanilla frosted and the 5 chocolate frosted that we have. So we'll cross those out because we can eliminate those. Since she does like glazed and she does like cinnamon sugar, we need to read carefully here. That's a total of 9. 8 plus 1 is 9 out of the 20 donuts. And that's going to get us 9/20. If you want to write it as a percent, that would be 45%. You don't need to do that, but 9 divided by 20 is 0.45. Again, we want to make sure we read carefully. It says, what's the probability that she gets a donut she likes? Eliminate the one she doesn't like when you calculate that. All right, so our last set of problems here, and then I think I do, let me check and make sure I put these problems here. It looks like I didn't. Um, I didn't put any independent practice in this. It may not be a bad idea to go back and rewatch some of the parts again as you're working through the practice sheet, just to get some extra practice with this. But in the meantime, let's look at number 17 through 22. We'll go through these problems and kind of discuss what their probability should be. 10 cards numbered 1 through 10 are mixed together and then 1 card is drawn. Find the probability of each event. Write your answer as a fraction in simplest form and as a percent. So number 17, when it says P6, You're not going to do 6/10. It's really tempting, but we have one card that's numbered 6 out of the 10 cards. So that is going to be 1 out of 10, which is 10%. Multiply top and bottom by 10 to get 10 hundredths, which is 10%. Number 18, what's the probability of selecting an 8 or a 9? Well, that is 2 out of the 10 cards. That reduces to 1/5, which is 20%. Again, if you're not sure how to write it as a percent, one option is just take top divided by bottom. 1 divided by 5 will get you 0.2, which is 20%. Number 19, what's the probability of selecting an odd card? So for this, we've got 1, 3, 5, 7, and 9 as our odd cards. That's 5 out of 10. That reduces to 1/2, which is 50%. Number 20, what's the probability of selecting a card that is less than 5? Well, that will include 1, 2, 3, and 4. That's 4 out of the 10 cards, which is 2/5 or 40%. Number 21, what's the probability of selecting a card that is not 6, 7, 8, or 9? Well, that would include 1, 2, 3, 4, 5, and don't forget about 10. That's 6 out of the 10 cards, which reduces to 3/5, which is 60%. And finally, number 22, what's the probability of selecting a card that's divisible by 4? That would be the card that has a 4 on it and the card that has an 8 on it. So that would be 2 out of the 10 cards. That's 1/5 or 20%. So here's what I'll do. If you feel like you want some additional practice, I will make a video with some independent practice for you as well that you don't need to watch if you feel pretty good about this. But I'll put that up here with your week 3 assignments also, so that you can maybe try some independent practice before doing the assignment that you need to turn in. After doing this, you may want to do assignment 1 since it's based on this video, or you can watch the other videos and then do assignments 1 and 2 together, whatever works best for you. Thanks for listening.